Fridays, so that I can be able to do the question. Right? Do you remember that one?
Yes, ma'am.
Yes, ma'am.
Okay, I haven't been receiving a lot of problems, so I don't know. Should I say good for me, or you guys? Should I assume you guys understand the work?
Ma'am, for me, question 4 on the post-test for successive differentiation, if we're able to go over that sometime, would be great.
But I can't go over it if you didn't go over it first. I
No,
need
I
to
have
see proof. You have to send it to me first. It's an eye for an eye. We exchange. Which color are we using this week? It's an eye for an eye. We're exchanging. So you should send it to me first, and then I will work on it together. Guys, which color are we using today?
We're using red, ma'am.
Red.
This group. Red for danger. Hey, telling
Red for love.
Ooh. You, Mr. Valentino. Okay, so there was a question that was sent via email. So I'll start with that question. It's on page 28. It says, ma'am, I'm not getting what they're getting in the post test. So can you please do that question? Now, when in the exam I say simplify completely, I want you to do it completely. So what they did in the post test on page 28, post test 3, number 4, they simplified completely. So that's what you need to do in the exam as well. So what do they mean by that? Now we have 4. So this is how the question looks like. It says differentiate the following with respect to x using logarithmic differentiation. Now, logarithmic differentiation is what we did last week. So let's look at this example. So y is equals to the square root of 1 minus 3x over 1 plus 4x. Right? So we want to see if we can be able to find the answer that is in the study guide and how they did it. Now, in the exam, I'm not going to say differentiate the following with respect to x using the logarithmic differentiation or using the chain rule. You need to know which method you have to use. I hope I'm recording the class. Am I recording the class?
You are.
Thank you very much. Otherwise, I'll blame you for not having the recordings. Okay, so here, what's the first thing we do? You guys did logarithmic differentiation with your lecturer last week. What's the first thing we do?
Say y is equal.
We're going to simplify.
Guys, we can all sing, but we cannot all talk.
We can all put it to the power of 1 over 2 and then log both sides.
Thank you. So we can simplify this and say, okay, fine, this is 1 minus 3x over 1 plus 4x. Oh, I have a new pen and it writes very nicely. So therefore, take the log both sides. That's the rule for logarithmic differentiation. And I will not remind you about the rules, but we know if we have a power, we can then write this as 1 over 2 ln of 1 minus 3x over 1 plus 4x. So then this is equal to, now you need to be very careful. You know that ln of A over B is equals to ln of A minus ln of B. We all know that, isn't it? According to what we have learned last week. Now, there's a number here. Before you do that, put in the brackets, guys. It's a mistake. It looks like it's a silly mistake, but it's a mistake that a lot of you guys do. And then you end up not having full marks and you want to blame someone. So then this is equals to that. So we then say, okay, fine. Now that we have the half outside, we can multiply inside, or we can leave it like that for now. Which one do you want? Leave it like that, have it inside. Anything
Have
is
it
fine in
inside.
maths.
Have it inside, ma'am.
Thank you. Anything is fine in maths as long as it makes mathematical senses. Minus 1 over 2 ln of 1 plus 4x. Is there anything else I have to do, or I can now differentiate? To
Yes, you can now
simplify, or I can now
differentiate.
thank you. So meaning that
You
ln
can now
of y
differentiate.
is equals to 1 over ln of 1 minus 3x minus 1 over 2. Please mute 1 plus 4x. Right? So now we can differentiate. And we know that the derivative of ln of a function, I just remind you, and I'm not going to remind you again. The derivative of that is f of prime of x over f of x, meaning that this will be 1 over y times the derivative of y, and we know that the derivative of y is 1, but because we are differentiating y and y is a function of x, therefore this will be dy over dx. This is equals to 1 over 2, and this will be equals to 1 over 1 minus 3, and the derivative of 1 minus 3 is minus 3, minus 1 over 2 times 1 over 1 plus, put this in brackets, guys, so that it doesn't confuse you like it's confusing me right now. So this is plus 4x times the derivative of 1 plus 4x. This is 4. So then this is
Ma'am,
like this.
sorry.
Yes.
If you're taking the half out of both, then you need to do that.
Oh, sorry. Sorry, now I'm looking at what I'm doing. Thank you very much. Let's look at the above. Sorry. So this is 1 over 2 times 1 over 1 minus 3x times 3 minus 1 over 2 times 1 over 1 plus 4x times 4. Am I okay now? Yes, no?
Yeah.
Okay. So now this is equals to, so this is equals to, look at this. So this is 1 times, this is the same as 3, you can write it as a fraction. So this is the same as 3 over 1. This is the same as 4 over 1. So it's 1 times 1 times 3. We know that's 3 over 2 times this expression times that. So that's 2, 1 minus 3x minus 4 over 2, 1 plus 4x. Are we all together? Yes.
There on the it's -3 there on the numerator.
Oh, thank you very much. -3. Are we all together now?
Yes.
Okay. So right now, normally this is what we'll say: dy over dx is equals to times y, isn't it? Then we say minus 2 over 2, 1 minus 3x minus 4 over, for now, can we leave it as 4? Don't divide for now. I just want to show you something. Are we all together there, guys? This is how we
Yes.
normally left it, isn't it? This is
Yes,
how
ma'am.
we normally left it, isn't it? But because we know y, thank you, we substitute y. So in this case, our y is what? The square root of 1 plus 3x over 1 plus 4x. Open brackets, minus 2 over, why am I saying minus 2, guys? Minus 3.
Minus 3.
Thank you, minus 3, 2, 1 minus 3x minus 4 over 2, 1 plus 4x. Are we all together?
Yes, ma'am.
Yes, ma'am.
Okay, so now the reason why it's not the same as the one in the study guide, it's because the one in the study guide was simplified completely. And if you're asked to simplify completely, you have to simplify completely. Are we all together in this department?
Yes,
Yes or
ma'am.
no?
Yes.
Okay. Now, in most cases, me, I don't like putting the half inside. I like leaving the half outside for now, because then it doesn't give me a lot of confusion. So can we take out the half? So if I take out the half times 1 minus 3x over 1 plus 4x. Guys, you don't really have to take out the half, but for me, because it simplifies things, I'll take out the half. For you, you can say, okay, 4 divided by, then you are left with 2 and whatsoever, and then simplify from that. That's not a problem as well. Or let's do that rather. Let's not take out the half. Let's do that rather. So from here, right, you need to simplify completely. Where can I simplify? What do you think I have to do for me to simplify completely? Please help.
Find the common denominator.
Find the common denominator. What is the common denominator?
1 minus 3x, 1 plus 4x, if you've taken out the half.
Okay. If you don't take out the half,
Then it's 2, 1 minus 3x, 1 plus 4x.
are you all comfortable on how to find it?
Yes, ma'am.
Yes, ma'am.
Or you can also do the cross multiplication and multiply the denominator.
It's not called cross multiplication.
It's not really, but it's something like that. I just don't know how can I show it because it's more like a practical thing.
Okay. So last week my first just told me and reminded me to call the butterfly method. Do you remember the butterfly method, guys? Or you are old, you don't want to look at butterflies.
Yeah.
So they say that if you are adding and subtracting in fractions, your denominators have to be the same. So you put the if the denominators are the same, you put the denominator the way it is, you add or subtract the numerators. Now, for example, if you have 1 over 7 plus 1 over 2, that since the denominators are not the same, you can take this and multiply here and take this denominator and multiply there. Right? So then this becomes 2 over 7 times what? 7 times 2, that is 14 plus 7 over 14. Now this butterfly method makes your denominators the same, so then you say 2 plus 7. So we're going to do like that as well, so that the denominators look the same. Are we all okay? Are we all okay there? If you don't know how to find the LCD. So let's go and do it. If it's still not clear, guys, you should let me know so that I increase the thickness of the pen. So then we know that dy over dx is equals to the square root of 1 minus 3x over 1 plus 4x.
Ma'am?
Yes.
Oh, okay, it's fine. I think maybe it's my network. I think it's what you're saying. It's just showing it after. I think maybe it's my network. I don't know.
Can I try again?
Yeah,
Yes,
there is a
can you
slight
please?
delay.
Yes, please.
Okay, let me try again. So I say that dy over the dx. Are we together now? Or is it still giving the issue? 1 minus 3x over 1 plus 4x. Is it still giving the issue?
Yeah, it's still slightly delayed.
Yeah, there's a bit of a delay.
Yeah, it is.
Phone, let's see if we can change the network. But I think there might be load shedding somewhere, and then I don't know what doesn't connect to the what, guys. You'll tell me if there's a slight delay. I just need to change it to my phone data. Data. Please let me know if there's a slight delay again. So then minus 3 over 2, 1 minus 3x minus 4 over 2, 1 plus 4x. No delays, right? Hello?
Still the
There's
same.
still a delay.
Oh, thank you. Thank you. So now let's look at this. Let's look at this. We can remove the 2 to make it simple for us, guys. Or we can leave it like that. Now, look at this. Okay, let me make space. So this is the square root of 1 minus 3x over 1 plus 4x. Open bracket minus 3 over. Now there's a 2 here. 1 minus 3x. Do you see there's a 2 here as well? Guys,
Yes, ma'am.
there's a 2 here, there's a 2 here. The only difference is these things. Do you see them?
Yes, ma'am.
Yes, ma'am.
So then take the difference, which is this one, multiply it this side. Take this one, multiply it that side. So let's do that. So this is times 1 minus 3x. The denominator on the other side is 1 minus plus 4x over 1 plus 4x minus 4 over, the only difference is this. So it's 2, 1 plus 4x times 1 minus 3x over 1 minus 3x. Are we all together in that department? Guys, good.
Yes.
So then this is equals to the square root of 1 minus 3x over 1 plus 4x, open bracket. Now let's multiply. Negative 3 times this, it's negative 3. Negative 3 times plus, negative 3 times, what's this? Oh, sorry. Positive 4x. So it's negative 12x over 2 times 1 minus 3x, 1 plus 4x. Then minus 4 times 1, that's 4. We need to be careful here, guys. Can someone tell me why we need to be careful here?
Because of that negative sign outside.
Thank you. Because of the negative sign outside. So this negative sign, we can make it positive and then make minus here. I've noticed a lot of people making mistakes. So let it be minus 4 over 2, 1 plus 4x. Do you see that? Think of it like that. Because it does, trust me, it does make, you will have issues if you don't consider that part. Because I almost did the same mistake. So even if you don't consider like that, but you can still say minus. So this is minus 4 times 1. So that is what? Minus 4. Right? Are we all together there?
Yes.
Yes, ma'am.
And
Yes,
then
ma'am.
minus, and this times that, so that's plus 12x over what? Over 2, 1 plus 4x, 1 minus 5x. So if this, you consider it, so this becomes minus.
Minus 3x.
Where's minus 3x? Thank you, minus 3x. I'm just making you aware of the negative sign so that it doesn't confuse you. So this is then equals to the square root of minus 3x over 1 plus 4x. Now, the same denominators, we take them the way it is. So it's 2, 1 minus 3x, 1 plus 4x, like that. So it's minus 3 minus 12x minus 4 plus 12x. Be careful of the signs. So then this is equals to. Now, look at this, right? Do we agree that I can write this as 1 minus 3x to the power of half over 1 minus 4x to the power of half? Do we agree with that?
Yes.
Do we all remember that, guys?
Yes.
Your surds notation, the square root of a over the square root of b is the same as the square root of a over b, and the square root of a times b is the same as the square root of a times the square root of b.
Sorry, ma'am.
Your surds notation. Okay?
Sorry, ma'am. Can't we just put them in the
Yes.
second bracket and then we put the exponent, which is 1/2, a single exponent?
You can. Remember, this is the same thing. You can. As I said, if you have, isn't that what we have, right? Currently, what we have is the square root of A over B, right? So then we can write it as A over B to the power of half. But we know this is to the power of 1. This is to, so according to exponential law, this times this is A to the power of 1/2. This times this is A to the power of 1/2. So that's what we get here. Are we all together there?
Yes, ma'am.
Thank you.
Yes, we're together.
Sorry, ma'am, the denominator there, I think it's supposed to be 1 minus 4x.
1 minus 4x.
I mean, it's supposed to be 1 plus 4x.
1 plus.
What did I write, Khanti?
Minus.
Oh, guys.
1 minus.
The denominator. Oh, yeah. I'm sorry. Me, I'm looking at here. Thank you. Plus. Together. Are we together
Yeah.
there?
Yes,
okay.
ma'am.
So now look at this. Before we look at that, okay, let's just simplify. This and this, they cancel. That's what we call canceling, not dividing and canceling. This and this, they form -7 over 2, 1 plus 3x, and 1 plus 4x. Are we all together up to that point?
Yes, ma'am.
Yes, ma'am.
Now, what can I do? Because I need to simplify further, guys. Simplify completely or simplify further.
So the other numerator, 1 minus 3x, you can put to the power of 2/2. And then you can cancel the 1 minus 3x to the power of 1/2 out with the bottom.
Then you cancel the 1 minus to the power of half, because at the bottom it's 1 minus to the power of 3x.
Yeah, because that's 2/2. So it'll be 1 minus 3x to the half at the bottom.
Now let's look at this. Can I do something so that it simplifies our work? Guys, can I do something so that it simplifies our
Yes.
work? So that you see it properly. Let A is equals to 1 minus 3x to the power of 1/3, 2, right? And then let B is equals to 1 plus 4x to the power of 1/2. Are we all together there? We're
Yes,
just
ma'am.
simplifying our work. You can, it's easy to see when it's like this, but you can continue so that I show you something. So I, not to the power, right? So then we know that this is A to the power of 1/2 over B to the power of 1/2 times -7 to the power of 2 to the power of A times B. Do you see that? So this is
Yes.
-7A to the power of 1/2 over, what's this? Now look at this. This is 2A, isn't it? 2A. Now, what do we know? When we multiply two bases, when we multiply exponents with the same bases, what do we do to the powers?
You add them.
Thank you. You add them, right? Now, we know this B is to the power of what? It's to the power of 1, isn't it? So then this is B half plus 1. So this is -7A to the power of 1/2 over 2A times B to the power of 3/2. Do we agree there?
Yes.
Now, look at these two. They are dividing. When you divide powers of the same, what do you get?
Subtract
I
them.
mean, when you divide exponents of the same bases, what do you do to the powers?
Subtract the powers.
Subtract them. Thank you. So then this becomes -7 over, because you're going to subtract them, so it's going to be on top. So this will be 2B to the power of 3/2. Then it's A 1/2. We know that this is to the power of 1 minus 1. So then this is equals to -7A to the power of -1 over 2B to the power of 3/2. And we know, according to our exponential laws, if you have A to the power of -1, power of -half is the same as 1 over A to the power of half. Do you remember that?
Yes.
Thank you. So then this is equals to minus 7 over 2 times b to the power of 3 over 2 times a to the power of 1 over 2. Does that make sense?
Yes.
So now if we, because we said
Yes.
a is this, b is that, then we go and substitute. So therefore dy over dx is equals to minus 7 over 2, what is b? B is 1 plus 4 to the 4x to the power of 3 over 2 times a, what is a? 1 minus 3x to the power of 1 over 2. So that's the answer in the study guide. Do you see that, guys?
Yes.
If it wasn't easy for you to see it from this point of view here, to say, okay, this is actually equals to this, you can always try to simplify your expression. And when you simplify your expression, always remember to substitute back. So there, as they say, there's so many ways of killing a cat in maths, but you need to find a way, as long as mathematically the statement is correct. So more practice gives you more answers, more, you are able to do more. Are we together in that department?
Yes, ma'am.
Yes.
Thank you.
Yes,
So
ma'am.
I'm not going to do any other question because this is the only question I received during the emails period, right? But here, what we're going to do is we did logarithmic differentiation last week. Where's the study guide? Here. And this one that I have here. So we did logarithmic differentiation last week and something else. You can check what we did from the thing is from the video. But today, let's go and see what we'll be doing. We did successive differentiation because I know someone asked me about successive differentiation. So for me to do that question, meaning that next week I want you to send me the workouts and I see where you went wrong and then I explain. And then today we're looking at inverse trigonometric functions. Do you understand what inverse trigonometric functions are? Do you know them? Guys? So silence, should I assume silence means yes, we are okay?
No,
And
ma'am, we don't. I don't understand that.
Sorry, ma'am.
okay. Remember when in grade 12 when you're doing trigonometry, né? They will have like a Cartesian plane like this. Okay, let me draw. You'll have a Cartesian plane like this, and then you'll have a point somewhere with a point, like let's say the point is here, right? The point P, ne? XY. And then they tell you there's an angle theta here, right? And we know according to that is that we always hit to the x-axis for you to form a right angle triangle so that you can use your Pythagoras theorem. And then maybe yesterday you were given a 3 here, a 3 here, maybe a 4 here. So therefore you have to use Pythagoras theorem to find the other side. Do you remember that?
Yes.
Right?
Sorry,
Now,
sorry, ma'am.
yes. What was the sorry
Um,
for?
am I the only one who's experiencing, I don't know, it's network or what, like I'm having a challenge about when you talk and then the drawings come after. I don't know if it's my side or it's still the problem. Like,
Is it still a problem, guys? I hope it's not.
No, ma'am.
There's
Okay. I think it's your problem. It's an issue on your side.
okay.
Yes. So now we remember that, isn't it, guys? I'm forcing you to remember. If you don't remember, tell me you don't remember. And then we use your sign. You use your sign. What's this? You use your sine, cosine, whatever diagrams. Do you remember that? Or you don't remember?
Yes,
And you
ma'am.
also
Yes, we
use
remember that.
Thank you. And you also use what I call, when I teach, the Anastasia diagram, right? The Anastasia diagram. Some of you call it the cast diagram. You remember that? Are we all okay there? Then when you went to find the angle, you say sine of theta is equals to maybe SOHCAHTOA, right? Opposite over hypotenuse and whatsoever. Let's say 3/4, right? Now, the inverse of a trigonometric function is what will you use to find the angle for this particular ratio. When you say theta is equals to, in the calculator, you said arc sine of 3/4, and then you went and found some form of a degree. Do you remember that?
Yes, ma'am.
Yes, ma'am.
So then this is then what we call the inverse of this function. Are we all together? Now, if you take it to functions, you call it, remember when you had y is equals to, let's say you had 2x, and they said interchange y and x. Then you went and interchanged y and x. Here it became x is equals to 2y. And then now they say write in terms of y, like this. So then this was like the inverse of the function. Do you remember the inverses of function, guys?
Yes, ma'am, we do.
Yes, that's the inverse of a function. Now that you are in second year, there's something called composition of functions. I don't know if you did compositions of functions, but I did introduce composition of function. The word composition of function. Do you remember composition of functions, guys? Did you do composition of function? Do you know the word composition of function?
Sounds familiar. I think I forgot speaking for myself. I think I forgot, but I've heard of the name before.
Okay. When do we apply the chain rule?
When there's a function within a function.
Yes, that's the composition of a function. When you take one function and put it inside another function. Are we all together?
Yes, ma'am.
Now, there's something in it, it's called the showing that a function is an inverse of a function, right? In mathematics, when you have a function f of x and the inverse of f of x, if you take the function and put it inside another function, meaning that I know, okay, let's write g of x. Next, g of x is the inverse, like this, of f of x. That's what we know, isn't it? Are we all together? I'm trying to make a point here, because when it comes in the exam, people will say I didn't teach them. Now, when you have a function, your f is the inverse of g of x, right? Are we all together now? Meaning that you went to interchange the y and found the inverse. Your f is a function of g of x. Now, when you take f of x and put inside g of x, you'll get x. Did you hear what I just said?
Please repeat, ma'am.
Repeat, ma'am.
So we know that this is the function f. We go apply the rules that you did in grade 12, finding the inverse of a function. It's like when you had a parabola like this, you went and found the inverse and you notice that the inverse is not a function. Then you went and restricted and make a smaller nyana parabola like that. That was you finding the inverse of a function. Now, if I know f is the function and g is the inverse of the function f, if I put a function, if I take the function and put inside the function, I put g of x, which is the inverse, the answer by simplifying that will be x. Are we all together?
Yes, ma'am.
Yes.
Same
Yes,
applies.
ma'am.
If you take the inverse and put the function inside, then you get what? Then you get x. Are we all together? This means
Yes.
that if I take sine of the arcsine of x, then I'll get x. You can try that in the calculator if you want. Or if I take arcsine of and then sine of x, I still get x. Are we okay with that? Now, when you're taking a function and putting it inside another function, that's called composition of functions. I'm not going to explain anything further. I'm done. We shall see each other in the exam. Noted. Guys?
Yes, ma'am.
Yes.
Yes, ma'am.
Thank you. Now, you are going to read this top part here. It's what we explain that, okay, this is the angle and then this is what. Now they say note, sine to the power of negative x is used as a notation for arcsine x, meaning that in the exam, I can use sine to the power of negative 1x or I can use arcsine x. Those are the two notations I can use. So don't get confused and say, this one I didn't teach you. Now they are saying that the inverse of sine is not 1 over sine x, because the inverse of sine is equals to arcsine x. And 1 over sine x is everything in bracket to the power of negative 1. Are we all together?
Yes, ma'am.
Yes.
Thank you. Now they say following is a list of derivatives of the inverse trigonometric function. These derivatives can be found using standard differentiation techniques, including implicit differentiation. However, you are only required to apply and use the derivative directly. We supply you with the list of the standard form. You guys are happy, ne? Nyajabula, they give you the formula sheet. That's what they're saying. So they say that you do not have to worry or bother about deriving the formulas unless you're a mathematician. Deriving these formulas, they'll give you in the exam. If I don't give you in the exam, call me on Teams or call me on the phone. I'll make a plan that they appear. Are we all together? This
Yes.
table here.
Yes, ma'am.
Thank you.
Yes, ma'am.
Let's go to example 1. Now they say that if you're finding the derivative of arcsine, remember arcsine is represented as the same as this. It means that it's actually a function, derivative of a function over the square root of f of x squared. So that's what you're getting there. So we're going to use this one to actually solve our problems. So let's go to the first one. Let's go to the first one. Are we all together, guys? You see, guys, this thing is easy. You just recognize this is arc cos. And then it means you are using inverse trigonometric functions. Then you go and substitute. Okay, so this is arc cosec. Let's go and put it there. So since it's arc cosec, we go to the table. Where's the table? Let me go see the table. Where's arc cosec? Arc cosec is this one. Do you see that?
Yes, ma'am.
Yes.
Yes, ma'am.
So we then go
Yes.
and take a screenshot of arc cosec, which is this one, the derivative. Let's go and do it. For me, I like doing things on the side. For you, you can substitute the way they did in the study guide. Whatever works for you, as long as it gives you the right answer. Are we all okay there, guys? Am I losing someone?
Yes.
Yes, ma'am.
So now this formula says, okay, fine. You want the derivative, you want f of x, and you want the square root of that. So for me, I like doing step by step, meaning that I go and find I know that in this case, what is f of x, guys? In this case, let's look at our thingy. What is f of x? Do you see this
1
is
plus.
Minus 2x.
Thank you. So meaning that our f of x is equals to 1 plus x squared, right? So what is the derivative of f of x? The derivative of f of x is equals to 2x. The reason why I like doing it like this is because sometimes the expression inside is very complicated. Then I go and substitute. So dy over dx. Be very careful. Do you see that there's a minus here
Yes,
in the
ma'am.
formula? Put it minus f of x, the derivative, which is this 2x, over what is f of x is this one. So that is 1 plus x squared times the square root of f of x. Do you see that? 1 plus x squared squared minus 1. You're not done, guys. If you leave it like this, you get 0.5 maybe. Now we need to come and simplify. Let's simplify. So then this is equals to minus 2x over 1 plus x squared, please mute, square root of 1 plus 2x squared plus x to the power of 4 minus 1. Do we all remember how to simplify the squared very quickly, isn't it?
Yes.
Yes.
Thank you. Thank you. We don't have to open brackets. We are second years. We are more experienced. So this is equals to, I'm joking, you can always do what you want as long as it's work. Correct. So this is 1 plus x squared. So I see this minus there. And then we have 2x squared plus x to the power of 4. Are we all together?
Yes,
There.
Yes.
Thank you. What else can I do there? What can I do? What can I do?
Let's do this correct.
You can simplify your rooted equation.
Okay, by simplify, what do I do? What can I do?
You can say it's root 2 x 2 over 2, which is 1, plus
So you say,
x to the 2, using the exponents.
please repeat. You're saying?
You can say you can root the whole thing. So you can say root of 2 x of 2 by 2, or 2 divided by 2, which is 1.
So you're saying I should root the which entire thing?
The 2x squared plus x to the power 4 part.
Yes, it's rooted all of it, isn't it? Because I think I'm not understanding. 2x squared plus x to the power 4, that's rooted, all of it. So what can I do to it?
Yes, you
There's a
can
common
take out
factor
a
of
common
x.
factor.
Thank you. We can take. So what is the common factor in this case?
It is x squared.
Thank you. So we can take out x squared times 2 plus x to the power of 2. Are we all together?
Yes, ma'am.
And we know that a times b is the same as the square root of a times the square root of b, right?
Yes.
So meaning that this is equals to minus 2x over 1 plus x squared times the square root of x squared times the square root of 2 plus x squared. I'm not losing anyone.
Yes, still good.
Thank you. And we know that the square root of a is the same as a to the power of 1 over 2. So the square root of a squared is equals to a squared to the power of 1 over 2. This times that, this is just equals to a. So meaning that this would just be equals to x, this part over here. So this is minus 2x over 1 plus x squared times x times the square root of 2 plus x squared. So now this x and this x, they divide each other, they form a 1, they do not cancel. So this is equals to minus 2 over 1 plus x squared, square root of 2 plus x squared. Therefore, dy over dx is equals to minus 2. Let's see how they wrote it in study guide. They say 1 plus x squared plus 2. Well done, ladies and gentlemen. Are we happy? Are we happy, guys? Are we happy? Yes or no?
Yes.
Yes, ma'am.
Yes,
Sounds
ma'am.
Buy a donkey. Buy a donkey. Thank you.
Shouldn't there have
So
been a
let's
root
go.
sign there?
Yes,
Yeah.
Shouldn't there have been a root sign?
there's been a root sign. Yes. Which is this one over here. Thank you very much. There's a root sign there. Thank you. So now let's go to the next one. Do you see that it's easy when you know, okay, this is what I just need to apply that. This is the module you need to find. You need to get all your marks. Are we all together, guys? If you don't get all your marks, it means you made few errors. But few errors, you know, we can be lenient when you are marking. When you're doing the right thing, man, we also are happy. And when we mark, we also become lenient. But if you're doing the wrong thing, the whole thing is wrong, guys. I can't be going to search for marks. So this is at sign. So meaning that you go to your booklet. Hey, this module is nice. You just copy. Let's go and copy. Arcsine. Where's arcsine? It's the first one. So let's copy. Derivative of arcsine. So what is f of x in this case, guys? What is f
2x
of x
plus
in
1
this
over
case?
3.
Here.
Plus 1 over
Like I said, you can do it in the study guide and be like how they do it, or you can do it separately. For me, I like doing it step by step. That's how I roll. I don't know what they call it. Cool kids, x plus 1 over 3. Now, what's the derivative of that? F of x is equals to f of x, guys, mute. The person who's on the phone, can you please mute? So this is no.
Bloko.
Rifunze. With disable Rifunze, she will not speak again for this class. So now it's 2 over 3. So according to this, they say dy over dx. I go and put the derivative, which is 2 over 3 over there, over the square root of 1 minus f of x is 2x plus 3 over, oh guys, my brain, 1 over 3 squared. Guys, as I said, in maths, if you use the right rule to simplify, then it's okay. Right? Are we all together? Maybe you can tell me what should I do next year? Yes, Helen, you can talk. Don't raise up your hand. You can talk. You see, I only saw you after 10 years. You can talk.
Okay, ma'am. I just want to ask the derivative of f of x. You put 2 over 3. Isn't 2 a whole number and a 1? Don't we take them out and we left with 2?
Danny,
Uh,
are you differentiating f of x?
yes.
Okay, how are you differentiating it? Let me hear, how are you differentiating it?
Okay, it's 2x plus 1. 1 and 3, they are whole numbers. They don't have an x. So do I leave 3 and remove only 1?
No. So look at it like this. When I have fractions, right? When I have a over b plus c over b, the answer is what?
If you have a over b
Plus c over b.
it will be 1.
Look at it. A over b plus c over b.
A plus C over B.
Thank you. Because with fraction, this one and this one are the same. So you leave it like that. And then this becomes A plus C. Do you see that? So with this one, this rule over here, you can also apply it here. Because you have 2x plus 1 over 3, which is this one here. So then this you can also write as 2x over 3 plus 1 over 3.
Okay, so the denominator, when we differentiate, we leave it as it is.
So when you differentiate the denominator, look at this. You don't have to, because you can use the quotient rule on this one, but the easy way is to simplify it like this. So when you differentiate, remember when you differentiate a constant times x, the answer is always a constant. Plus 3. When you differentiate this, this will be 0.
Okay.
When you differentiate a constant plus x according to the standard rules, the answer will always be that number. If you differentiate 1 million over 5,000 times x, the answer will always be that 1 million over 5,000 times x. So that's why the answer is 2 over 3.
Okay, so it means denominator we leave this as it is. Thank you, ma'am.
Yes.
Thank you.
Any other question? Guys,
No,
any question? No question?
No, ma'am.
Okay, so now what can we do from here? Let's help each other. We need to help each other. Help each other here. So that we see that, because I noticed there are people who go into the study guide and say, oh, step by step, the next step is, and then they don't get what they're supposed to get. So here I want us to, even if we don't do it exactly the same way as the study guide, we do it in another way. So that we see there are so many ways of getting to the same answer.
Shouldn't
When
we
it comes
square
to
the bracket?
Okay, let's square the brackets. 2 over 3 over square root of 1 minus square the bracket. So this will be 2x plus 1 squared over 3 squared. Are we all okay up to that point?
Yes,
Don't
ma'am.
copy from
Yes,
the
ma'am.
study guide. I want you to do what your heart is telling you to do, and your heart is telling you to do. If it's correct, then it's correct. Then what do we do?
Can we put the whatever's underneath the root sign over a common denominator of 3 squared? So you do the butterfly like we did with the other one.
Okay, are we all understanding what she's saying, guys? Hello?
Yes.
She's saying that because look at this. We have a fraction. Remember we said we have a over a. We have a plus b over c. And we are doing a fraction. So we have a fraction and we're adding a fraction to some constant. So she's saying, okay, fine. What we can do is, but remember, we want to change the other one to a fraction first. And any constant can be changed to a fraction by dividing by 1. So we can say 1 by 1. Do you see that? So then minus 2x plus 1 squared over 3 squared. So she say we do the butterfly method. So then we go and say, because the denominators are not the same, here it's 1, here it's 3, we take this 3 and say 1 over 1 times 3 squared over 3 squared minus 2x plus 1 squared over 3 squared, and take this 1 times 1 over 1. Just doing it step by step. So then this is 2 over 3 divided by, look at this. So then this is 9 over 9 minus 2x plus 1 squared over 9. Are we all together? Yes or no, guys?
Yes.
So we are doing it differently compared to how they're doing it in the study guide. Do you see that? So now this is 2 over 3 divided by square root of 9 minus, let's simplify this, over 9. We know that this will be over 9. Let's simplify this. What will be this inside now?
It's going to be 4x squared
4x squared.
plus 4x plus 1.
Are we all together there?
Yes.
Yes.
So what can we do from
Yes.
this? We are doing it differently from the study guide. Then what do we do? I want you to tell me.
You would say 10 minus 4x squared plus 4x over 9.
Okay. So what you do is you then say, okay, look at this. This is 9. This times this is minus 4x squared. Negative times this is minus 4x. Negative times this is negative 1. Why are we getting 10? I had 10.
Sorry, that's 8.
Thank you. So over 9 still. But something is bothering me here. But let me not talk about what's bothering me because it's not important. Let's continue. 3 over 2 over the square root of. So this is what? Look at this. So this is 8 minus 4x squared minus 4x over 9. Am I done?
Can you not take the 3 underneath the 2 to the bottom using your fraction laws? So say 2, 3 roots of 8 minus 4x squared minus 4x over the root of 9, which is 3.
You don't just want to take. You need to apply some form of a rule.
It's a fraction.
Let's not say take. Let's not talk
Um,
about take.
It's your
Because what
fraction
you
rule. So you'd
Yes.
say 2 over 3 times 1 over the root of that whole fraction.
Okay. Before we do that, can we simplify what's in the root? Because you can see it doesn't look nice. Before we do that. Let's simplify what's in the root because it doesn't look nice.
We can take 4 out as a common for the numerator and the root.
Thank you. So we go take 4 out. Do you see that? So that's 2 over 3 divided by, let's take out 4. So this is 4. Then we're left with 4 minus 2x squared. I'm lying. Minus x squared. Is it squared? X squared. Guys,
2 minus x squared.
thank you. 2 minus x squared minus x over 9. Then what can I do? Always simplify what's complicated first.
So
I
the
always use the
4,
root.
you can use your root laws there.
Thank you. Look at this. Look at this. 2 over 3 divided. Do we agree that this can be written as 4 over 9 times 2 minus x squared minus x? Do we all agree, yes or no?
Yes.
Yes, we agree.
Okay. Let's take this. We don't have more space. I want you to practice to see that not what you see in the study guide should be exactly the same way that you do. Some people solve problems in a very short step. Some people solve problems in long steps. From here, do you remember the rule that says a times b is the same as the square root of a times the square root of b? Do you remember that rule?
Yes.
Yes,
So
ma'am.
meaning that this is 2 over 3. We can write this as the square root of 4 over 9 times the square root of 2 minus x squared minus x. Did I lose someone there?
No, ma'am.
No, ma'am.
Okay. Do we all agree that the square root of a over b is the same as the square root of a over the square root of b? So it means that I can write 2 over 3 over the square root of 4 over the square root of 9 times the square root of 2 minus x squared minus x.
Yes.
So this is 2 over 3 over, what is the square root of 4?
2.
It's 2,
What is the square root of 9?
3.
Times the square root of 2 minus x squared minus x. This and this, they divide, so this is equals to 1 over square root of 2 minus x squared minus x. Are we all together there?
Yes.
ma'am.
Yes, ma'am.
So, because people look at the solution and they say, hi, I have to do the step, I have to do the step. If you are doing the steps according to the rules of maths, then you are right. You are right. Because there, when the lady says, do the fraction here and here, it might have made the expression look more complicated. You can still do that at that particular point. But if you know that I can first simplify the hard part first and then come after and do the remaining part, then that's still okay. Can we look at another example? I'm just showing you how I solve maths. I don't look at the solution. I was like, okay, this is what they want me to do. Let me solve it then. That's how I solve it. Okay, let's look at example 3. Did I lose anyone, guys? I hope I'm not losing people.
Ma'am, can I ask?
Yes.
Okay, I got the same answer. However, I did flip around the fractions. So I wanted to ask if will that matter when it comes to your marking?
No, it won't matter. If you mean flip around fraction, that's what I think the lady was saying. But I can show you something else that I also like doing as well, which is the flipping around of fractions. So if you get to the same answer and what you did is correct, then it's fine. Then it's fine, because when we mark your steps. Are they correct? Or you used Greek, but Greek combined with Chinese to answer your question? Because some people are magicians, they just get answers. I don't know how. And that's wrong. So example 3 is an arcsine. So let's go and see what an arcsine. Oh yeah, this module is nice. You just go see where it is and then you copy and paste. And then you solve. So we see arcsine, you are here. Let's take you up here. Copy. There we go. We paste here. So what is f of x in this case? What is f of x in this case?
Into 1 minus
Thank you.
with the exponential half.
Thank you. Who tried this example in 44? Should I give you as a homework?
Yes, you can.
I'll give you this one as a homework. I have a reason why. I have a reason why. Can you please try it and then next week we redo it? That will be the first question. Are we all together? Or maybe what we can do is let's finish all the questions for this chapter. We finish the next section and then I give you 5 minutes to try it and then we do it together. I think that will be, because when I did the question, there's something I noticed that I would like to share, but I can't share if you guys don't share it first. So let's go to the next one. We'll come back to this one. The next one is example 4. 4. Okay, screenshot. Example 4 is an arcsine. So let's go and copy arcsine. Copy, paste there. Paste. And then where is our study guide to see the answers? Formula sheet, where are you? Arcsine is the first one. The only thing here you need to know is be able to solve. And the more you solve, the more you learn the tricks of solving. That's algebra for you. The more you do algebra, the more. So then this, please mute whoever is drinking Coca-Cola or Fanta or water. And whoever is typing a love letter. Thank you.
Sorry.
So now we have arcsine. We know how the drill works, guys. We know f of x. Come on, f of x is 2x minus 3 over 3x plus 4. Hey, how do I differentiate this? Please help me. You can differentiate the way they differentiated in the study guide, or you can do what I'm doing currently right now. Differentiate it on the side first. It's also allowed. Which rule can I use here?
You can use logs, or you can use your quotient rule.
Quotient.
Why not logs?
Either way, ma'am.
Either way.
I'm saying you can apply the log, or you can solve using the quotient.
If we apply the log, go and apply the log and see what happens. Let me not tell you. I don't want my brains to solve for you. Go and apply the log and tell me. Did we ever take a function inside a function and then apply the log to that function that was inside a function? Did we do that?
I thought, ma'am, that was merely to resolve the derivative of f at x.
But we never took a function inside a function and applied the log.
Okay, ma'am.
Have we done that? Or we always had y is equals to something, then we apply the log?
I haven't dwelled much onto it, so I don't want to comment so much.
Okay, so the lady, because there was a lady who said we apply the log. Did you take a function outside and then apply the log? Inside a function, then apply the log?
Well, I suppose we can try and see what happens.
Thank you. Let's go and try and see what happens. Now, in this case, which one is the easier one? Because it's one function on top and one function at the bottom. What do we use? Guys? What do we use when we have one function at the top and one function at the bottom and want to differentiate them?
Quotient. It's a quotient, ma'am.
Thank you. So we then say f of prime of x is equals to 3x plus 4. I'm not going to go over the quotient because I'm assuming you are the betas by now, which means you are the gurus. You are good. 2x minus 3 and 3 over, you should be telling me if I did wrong or not. There we go. So from here, this is equals to 6x plus 8.
There should be a square at the bottom.
Thank you. You see? Thank you. I taught you well. Thank you very much. 6x minus 9. I need to take credit, guys. When people are not giving you flowers, you buy yourself flowers. So this is equals to 6x plus 8 minus 6x plus 9. So this is equals to, what is this? What is this? 17 over 3x plus 4 squared. Do you see how it was? It is. Guys, me, I like doing, that's why I like doing things on the side. then it gives me this answer. Are we all together?
Yes.
Yes. Thank you. So let's go and substitute. So they say dy over dx is equals to the derivative. So in this case, can I show you something? Sometimes I don't like writing things like this, right? You see, this is a fraction, guys. Ne? So they say dy, let me write it here because I need space. Dy over dx is equals to the derivative, which is 17 over 3x plus 4 squared, divided by the square root of 1 minus what? 2x minus 3 over 3x plus 4 squared. Are we all together there, yes or no?
Yes.
Now there's this rule.
Yes, ma'am.
You know I can write a over b as a divided by b. Is it true?
Yes.
So
Yes.
meaning that if I put them into fractions, this is equals to a over 1 divided by b over 1. I'm still right, isn't it? It still gives me this.
Yes.
So meaning that if I want to rewrite it back to this, I know that a over 1, flip this, times 1 over b. Then I get a over b. You remember that rule?
Yes.
Thank you. So meaning that you can simplify your work as well. If you can see that, hey, the top part, and then you have a lot of expressions in the bottom and the top, you can also simplify that and say, okay, I can write this as 17 over 3x plus 4 squared divided by the square root of 1 minus, we agree this will be 2x minus 3 squared over 3x plus 4 squared. Am I losing someone?
No.
Yes,
No,
no?
I'm
No.
still with you.
Okay. So which one can I simplify here now?
Under the square root.
Yes, that's the most complicated part. Let's do that. Let's simplify that for now. So it's 17 over 3x plus 4 squared divided by, what is under the square root? 1 minus, then we get what? How do I simplify it? I didn't ask. How do I simplify it first?
Wouldn't you all put it on, you do the butterfly method for it with your
Thank you.
3x plus 4 squared.
Thank you. We know this is 1 over 1. Then you multiply, so let's just put it here, 1 over 1. So then you multiply by this denominator, which is 3x plus 4 squared over 3x plus 4 squared minus 2x minus 3 squared over 3x plus 4, then multiply by 1 over 1. So then this is equals to 17 over 3x plus 4 squared divided by the square root of, look at this, 3x plus 4 squared over 3x plus 4 squared minus 2x minus 3 squared over 3x plus 4 squared there. So now the denominators are the same, so you take the denominator and do whatever you want to do with the numerator, x plus 4 squared. Now, divided by, are we together there? The square root of, so this is 3x plus 4 squared minus 2x plus minus 3 squared over 3x plus 4 squared. Then what do we do? From here, there's so many ways of killing a cat. What do we do? What do we do, guys?
We can split up the roots. So the root of the top divided by the root of the bottom.
Okay. Did you hear that, guys? Did you hear what she said?
Yes, ma'am.
Okay. Before that, someone else, what do you think we're supposed to do here? Well, I was thinking of something else, but we'll do that one. But someone else, what do you think we can do here? Okay, no one is saying anything. She's saying that we know the rule that says A over B is the same as square root of A over square root of B. So we can go and do that. So then this is equals to 17 over 3x plus 4 squared divided by square root of 3x plus 4 squared minus 2x minus 3 squared over the square root of 3x plus 4 squared. Then what happens?
Then we flip it around the last fraction.
Wait, before we flip around things. Before we flip around things, we can, let me just continue what you said and not give tips, okay? So then let's flip around. How do we flip around? Let's go back to our math rules. We know that if we have A over B divided by C over D, to actually solve this, we say A over B times flip around. So D nominator becomes the numerator. We're all okay with that rule, isn't it? Thank you. So then we can flip around. So this is 17 over 3x plus 4 squared times now. This becomes on the top becomes the bottom. So this is square root of 3x plus 4 squared over the square root of 3x plus 4 squared minus 2x minus 3 squared. Are we all together? Yes or no, guys?
Yes.
Then what?
If we wanted to, we could say let A equals 3x plus 4. And let B equals 2x minus 3. Substitute it just so it looks simpler and then simplify.
Before that, I don't want you to do that because if you look at it under the square root, that thing is not simplified. Do you see that?
Pardon me, ma'am. If we
Yes.
can say though in that in the denominator, we can say we can split the square root in both sides as in square root 3x plus 4 into the power squared all under the same square root, and then we say minus square root of 2x minus 3 all squared. Won't that give us a clear way of the pathway?
Thank you for raising that. Let's go back to our third rules. Our third rule says that if I have A times B, I can write the square root of A times the square root of B. But if I have A plus B, I can never write it as A square root of A plus square root of B. And if I have square root of A minus B inside, I can never write it as square root of A minus square root of B. Does that answer the question?
Yes, it does, ma'am. It does.
Thank you. What is the square root of A as an exponent? It's A to the power of what?
1 over 2.
Thank you. A to the power of 1 over 2. Now, if I have the square root of A squared, what is the answer?
It's 8.
Well done. It's A to the power of squared to the power of 1 over 2. And we know according to our exponential law, these two multiply. So this 2 times half is A to the power of 1, which is just A. What do you think this happens? What's the answer for that part?
The top part will just be 3x plus 4.
Thank you. I'm not saying what you guys are trying to do is wrong. There are certain methods where you just have to look at your rules. So the top part will be what? Will just be 3 plus 4 over square root of 3x plus 4 squared minus 2x minus 3 squared. Now, if we make A and B and C and whatsoever, do we agree that this has, okay, look at this, guys. Let me write it like this. Do we agree this is the same as? Now, isn't that here we are multiplying? So this will multiply by this one. Are we all together? 17 times 3x plus 4. We are together, yes or no?
Yes. Yes.
Thank you. Do we agree that a squared is the same as a times a? So this is 3x plus 4 times 3x plus 4 times the square root of 3x plus 4 squared minus 2x minus 3 squared. So meaning that this can divide one of them. So this is equals to 17 over 3x plus 4. Now that we have simplified everything, which part is remaining to simplify?
The square root of.
Thank you. So let's simplify the square root. What is inside the square root? We know the inside the square root, we have 3x plus 4 squared minus 2x minus 3 squared. So what is the answer there? So this will be what? 9x squared plus 2 times 4 times 3. 27. Am I right? No. 2 times, eh? Guys, help me. 2 times 4 is 8. Times 3 is what? 24.
24, ma'am.
Thank you. 24x. Then plus 16 minus 4x squared. 2 times negative 3, that's 6. Negative plus 2 minus 12x plus 9. So then this will be what? 9x squared plus 24x plus 16 minus 4x squared plus 12x minus 9. What will be the answer? Please help. This and this will be 5x squared.
Plus
This and this will be,
36x.
thank you, 36x plus
7.
7. Well done. So therefore, this is that. Is that the same thing that they did in the study guide? Yes. We used more steps, but it was simpler because we knew this is the rule, this is the rule, this is the rule, this is the rule. So as I said, there are so many ways of solving this problem, but you need to find a way of saying, am I applying the right rule? Am I applying the right rule? Am I applying the right rule? And what else did we learn here? What do you think we learned here, guys? By looking at this, what do you think we learned? Can someone say something? By looking at the problem. We didn't learn anything. So is it me only who learned it? Guys? Hello?
So it's the green section where you say a plus square root of a plus b cannot equal the root of a plus the root of b.
Well done. And then which other part? Things that we're reminding each other about the steps, and which other part? Whoever gets it, I'll give them a sweet.
That when you divide a fraction, you inverse into multiply and then inverse.
Okay, good. Which other part? There's the part where I'll give a sweet for it. If you see me on campus, remind me to buy you sweets. Which one is that? Should I say it, guys, or should I give you as homework? And normally when I give things as homework, I forget. And then I don't do them. Just being honest.
I see a difference of 2 squares. I'm not sure if it was there initially because I had to step out at some point.
It was always there.
Oh, okay.
But you see that you're not even, if you see me on campus, I was going to buy a sweet and then ngamlela for you half, like when you buy sweets and you bite it and you give the half. Guys, have you noticed that in the textbook, right, they simplified from the start here? Look at this. As soon as they simplified from here, they started taking the 3 squared and getting the answers here. They got the answers before. We simplified at the end. Do you see that? Do you see the difference? Not always you have to simplify at some point. See if simplifying there won't cause you complications or whatsoever. Was it necessary to simplify this part here? No, it wasn't necessary because we know we can also simplify it at the end. But if you go in your study guide, you will see that they simplified it immediately after step number 3. And they continued with it. Makes sense. The more you practice, the more you would learn these steps. Are we all together, yes or no, guys?
Yes.
Or someone is completely lost? My aim is to make sure that you guys see that you don't have to do it according to the study guide. You don't have to do it according to the textbook. If you understand your work, then you will be able to solve. If you understand your algebraic expressions, algebraic rules, exponential rules, the surds, and the fractions and everything, real numbers and whatever, fundamentals, that's the word. Therefore, you can be able to solve the problem. Understand the basics. Danko, and that's the first session.